Buddies and friends from Algebra 1. All right, so we're moving on to Lesson 14, Solving Inequalities. Now, if you notice, it says 2 days. I'm not sure if it's going to take us 2 days to get through this. I'm not sure whether or not it's going to take us just 1 day. But if it takes 2 days, it's not the end of the world. If it takes 1 day, I'm okay with that as well. All right, so solving inequalities. What will we need to actually do solving inequalities? Well, I would suggest that we have our books. You're looking at your computer, so you should have that. And you should have a pencil. I would also recommend, since we're going to be working with inequalities, I would recommend using a, I would go with making sure you have a ruler with you. If you have a ruler, try to make straight lines, okay? All right, so let's get ourselves started. All right, let's jump into what we're working on here. All right, so our standard and our objective are listed there, okay? So our standard today is going to be A1A.REI.B.2. Solve linear equations and inequalities in one variable, including equations with coefficients represented by letters. So what's the objective today? Well, the objective today is simply put, all right, we are going to be able to solve inequalities in order to determine the solution set of a given inequality and effectively graph the solution on a number line, okay? So let's start with looking at the problems we're working with, okay? All right, so Lesson 14, Solving Inequalities. Here's the problem, okay? Today I was talking to Coach Mullen, and we were looking at the problems together, and we talked it out, and we noticed something very interesting about this set of problems, okay? We really haven't worked with anything regarding quadratics, okay? So x squared is a little bit difficult to be able for us to work out. We got a lot of information in this problem that really makes it difficult for us to solve. So I'm not going to sit there and try to work through this problem with you. However, if you want to give this a shot yourself for homework and take a look at what you get, I'm okay with that. We could discuss it in class tomorrow and see whether or not what kind of answers you get, okay? All right, but for right now, I'm not not comfortable talking about this just for the simple fact there is that x squared in there, and we really haven't delved much into it, okay? But let's go ahead and keep on going. All right, so example number 1. What is the solution set to the inequality 5q plus 10 is greater than 20? Express the solution set in words, in set notation, and graphically on the number line. I'm going to explode this up a little bit, okay? Make it a little easier for us to see everything that's going on, okay? All right, now here's the thing about inequalities, okay? They are pretty much no different than equations. We're still going to have to solve them as if it's an equation, okay? Oh, well. So what is the solution set to the inequality 5q plus 10 is greater than 20? Express the solution set in words, in set notation, and graphically on the number line. So the first thing we're going to do is we got to solve for the variable. What is the value of q? So 5q plus 10 is greater than 20. All right, well, the first thing I have to do is I've got to get rid of everything that is not attached to the coefficient. That is the variable. So that means we got to start getting rid of everything that we can. Well, I don't want to do anything with the 5 yet, okay, because I could do something with the 5, but I really don't want to confuse you, okay? So the first thing I'm going to do is I'm going to try to get rid of this positive 10. So I'm going to subtract 10 because the opposite of addition is subtraction. So subtracting 10 from both sides. 10 minus 10 is 0, leaving me just 5q. Is greater than 20 minus 10, which is going to be 10. Now, this is multiplication. The opposite of multiplication is division. So we got to get rid of the 5 by dividing out the 5. 5 divided by 5 is 1, so it leaves me q is greater than 10 divided by 5 is 2. So I'm looking for values of q that are greater than 2. Okay? So the solution set is all values greater than 2. Okay? So all values greater than 2. That is your solution in word form. Okay? In set notation, what we're going to be looking at for set notation, Sorry, give me a second, guys. I'm actually looking for something here. Okay. In set notation, all right, you're looking for all values of Q that are greater than 2. Okay. And in a number line, okay, in a number line, all values that are greater than 2. So we're going to start down here. Here's 0. Here's a negative 2. Here's 2. Here's 4. Here's 6. And here's 8. Okay. Now, you need to remember two things, okay? I don't know if you remember them, but you should remember open circles and closed circles, okay? Open circles, all right, means value not included in solution. And a closed circle means value is included, okay? You'll normally see a closed circle on things like less than and equal to and greater than or equal to. You'll see open circles on less than and greater than, okay? So this one here is just greater than. So I'm going to put an open circle on 2, and then I'm going to darken my number line for every value that is greater than 2 that would solve this equation, or solve this inequality, sorry. So every value greater than 2 is a solution. 2.000000000000001, okay, is a solution. Okay, 2 and 100 trillionths is a solution to Q is greater than 2. All right? So let's keep on moving down. Find the solution set to each inequality, express in solution set in set notation and graphically on a number line. Okay? Well, this is going to be easy. All right. Just so we can go ahead and get some things squared away, D is going to be for homework. E is going to be for homework. Okay? Just so we go ahead and get that one out the way now. That's important for us to know. That will be for homework. Okay? All right. So let's work on our solutions. Okay? So we got x plus 4 is less than or equal to 7. Okay, so let's go ahead and solve this one. The first thing we have to do is we've got to get rid of that positive 4. So we're going to subtract 4 from both sides. Okay, x plus 4 minus 4, that gives me 0. So that leaves me x is less than or equal to 7 minus 4, which is 3. Okay, so in set notation, x is less than or equal to 3. In a number line, okay, here is 0, here's 3, and here's a negative 3, okay? We're looking at all values that are less than or equal to 3. So 3 does complete this equation, or inequality, sorry, I keep on saying equation, does complete this inequality, so it's a closed circle because 3 does equal 3. And then every value less than 3 is a solution, okay? 0 is less than or equal to 3. Negative 3 is less than or equal to 3. Those are all solutions. Okay? M divided by 3 plus 8 does not equal 9. Okay, well, remember, we can't touch this yet until we get rid of this, so we have to subtract 8 from both sides. So I got M divided by 3, 8 minus 8 is 0, does not equal 9 minus 8 is 1. Now, remember, when you have a denominator here, this is the same thing as saying 1/3 times M. To get rid of a fraction, you multiply by the reciprocal. Okay? So 3 divided by 3 gives us 1, so that leaves me M does not equal 3. Okay? So in this type of an equation, okay, and this is your set notation right here, is M does not equal 3. All right? So in this inequality, we are looking at 3, and we're going to put values here, 3 and 6. M is any number but 3. Okay, any number but 3 would satisfy this inequality. So that means I gotta highlight both sides of the number line and make sure that I put an open circle on 3, because we're looking for every value but 3 that satisfies this inequality. So every value but 3 satisfies it. All right. Let's look at C. 8y plus 4 is less than 7y minus 2. Okay. Let's go ahead and get rid of this 4 first, okay? So we subtract 4 from both sides, Okay? We have 8y plus 4 minus 4 gives me 8y is less than 7y. Minus 2 plus a negative 4 gives me a negative 6. Now I'm going to get rid of this 7y. I subtract 7y from both sides, okay? So I'm going to be left with less than a negative 6. 7y minus 7y is 0. Now remember, the y's are just going to come down. What's 8 minus 7? 1. 1 times y is y, so y is less than a negative 6. So that is my set notation. Y is less than a negative 6. Now I need to do it on a number line. Okay? So here's 0, here's a negative 3, here's a negative 6, and here's a negative 9. Okay? Is less than a negative 6. I'm looking for values that are less than negative 6. Now see, what I love about this, the inequality sign points you in the direction that you're supposed to be going. Okay? Look at the arrow at the end. You see that? That's an inequality. That's less than. So any value going to the left will be less than a negative 6. But do we include negative 6? No, we don't. Open circle. All values to the left of 9 are negative. Okay? So all values to the left of a negative 6 satisfy y is less than a negative 6. Okay? All right, let's continue on. Hopefully 3's on the next page. If it ain't, then we got to go back. But I'm going to come down here real quick. I want to make sure. Anything down here? Doesn't look like it. All right, so remember, D and E are your homework tonight. All right, so number 3. All right, we're going to do this for classwork tonight, okay? Want to make sure we do that for classwork tonight. Or for classwork tomorrow, okay? All right, we're going to save example 2 for classwork as well. Example 3 is what I want to get to. I want to make sure that we get to example 3. Okay? All right. So far, everything that we've dealt with is dealing with a positive exponent. Okay? Or positive coefficient, my bad. Now we're dealing with a negative coefficient. Okay? Whenever you, and I need you to remember this, whenever you multiply or divide by a negative coefficient, then you flip or change the inequality sign. Sorry about my handwriting. It's a little crazy right now. All right, so for example, if looking at negative q is less than, or negative q is greater than or equal to a negative 7, okay, I have to get rid of that negative q, okay? So what number can I multiply by a negative to turn it into a positive without changing the coefficient of q? Right, I can multiply anything by negative 1, making sure that the coefficient still stays the same. So I'm going to take a negative 1 and multiply it by a negative q. That'll turn it positive. Is greater than or equal to a negative 7 times a negative 1. Now, I'm about to do something here that you're going to be flipped out on. Negative 1 times a negative q is q. Negative 7 times a negative 1 is 7. This now changes direction and goes the other way. Is less than or equal to 7. So your set notation is now q is less than or equal to 7. That is your set notation. And I'll show you why this works out this way, okay? So here is 0, here's 1, 3, 5, and 7, okay? We're going to include 7. And then we're going to do every value to the left because we're going less than. All right. Now, why is this? Okay. Choose a value on this. Let's go with 2. Let's go back to the original expression. Negative q is greater than or equal to a negative 7. Substitute 2 in for q. Negative 2 is now greater than or equal to a negative 7. Okay, is this true? It is. It is true. Okay, that is true. Based on our information, it's true. Now, here's something I want you to try instead. Okay, look back at the original expression. All right, negative q is greater than or equal to a negative 7. Okay? So let's try it if we hadn't changed anything. So choose a value that is greater than a negative 7. Okay? Choosing a value that's greater than a negative 7. All right, well, let's choose a value that's greater than 7 itself. All right? Let's choose 10. Okay? Negative 10, all right, is now greater than or equal to a negative 7. Is this true? No, this is not true. A negative 10 is less than or equal to a negative 7. It's not true. We flip the sign so we can make sure that whatever value we plug in here is correct. Okay? Right now, if we left this alone, every value greater than a negative 7 would work up to 7. After that, it wouldn't work anymore. So we flip the sign so we can guarantee that every solution is an answer. Okay? Negative 8 is less than or equal to 7. Negative 15 is less than or equal to a negative 7. Okay? Even if you take those values and plug it back into the original, a negative of a negative 15 is a positive 15. 15 is greater than or equal to a negative 7. That is a solution, okay? You've got to flip those inequality signs when you multiply or divide by a negative, okay? This is imperative. Do not forget this, okay? It is important. This will haunt you until the day you leave math, all right? Okay, for homework tonight, I want you to do A and B for homework. Okay. I will do C and D as classwork. Okay. All right, and I will run 5 as classwork as well. Okay. All right, and we're going to stop right there, okay? This might actually take 2 days, so just relax and chill out, okay? We'll stop at 5 for the time being, and then if we have the time tomorrow, we'll continue going through the lesson, but for right now, yeah, we're going to stop at 5, okay? All right, so with that being said, I want you guys to have a good evening. I will see y'all bright and early tomorrow morning. Hopefully you watch the video and do what you're supposed to do. Night, guys.